Okay, Assalamualaikum and a very good afternoon. Uh, Here we will continue again 6.4 influence lines for floor girders. Yeah? So this subtopic is to show you how to draw an influence line for a floor girder specifically in a building structures. So we know that based on this diagram you have a slab, yeah, and then below the slab you have a floor beam. So normally loading from the slab, yeah, will transfer to the floor beam, yeah. All the loads from the slab, typically loading from the self weight of the slab, and any loading on top of the slab will be transferred to the floor beam, and then it will be transferred to the girder, yeah. So will be transferred to the girder, and then loads from the girder will end up transfer to the column, yeah. So this is how the loads from the floor is being transferred from slab to floor beam to girder and to the column, yeah. So first here, second to the floor beam, third to the girder, and the fourth to the column. So if you cut the section, so this will be the this will be the cross section of the girder, yeah. So this is the cross section of the floor girders, yeah. So you can see if you want to draw the influence line, you need to place one unit, yeah, one unit of load along the floor girders, yeah. So you can move from A to B and to C, yeah. Here, so the influence line for a specific point on the girder can be determined using the same static procedures. So as usual, when you place the loads, then you can do cut section, yeah. So the value for the internal moment in a girder panel will depend upon where point P is chosen for the influence line, yeah. So the moment will depends upon the point's location. It depends on the cut section that you will do. Okay, if we refer to this 6.206, 6.2C, yeah. For example, you want to see what is the okay, if a unit load act on the floor slab, yeah, like this. So you want to see what is the internal shear VP, yeah, here. So you want to see what is the internal shear at P. So means that you need to place a unit load on the floor girder first, yeah. So here, let's say you place one unit, and then you need to find the support reaction, yeah. First of all, find the support reaction here. So based on this one unit being given to the floor, find the support reaction at FB and then at FC. So once you know that, this will go as a point load at C and B, yeah. So once you have this B and C, then you can calculate, you can calculate the F1 and then calculate the F2, yeah. So once you know the support reactions at F1 and F2, then you can cut, yeah, using method of section. So using this method of section to find the VP, yeah. So you cut here, and that it will goes to this, yeah. So this will go to this. So you cut the section, you already know the F1, you already know the FB, then you can find the VP, yeah. So this is what we call method of section, meaning that you can use the static procedure as usual. So here in this case, VP will be constant throughout panel BC. Yeah. So influence line for the shear in floor girders are specified for panels in the girder and not specified points along the girder. So means that it is only applicable at specified points. Yeah. So this shear is known as girder shear. Okay, now we move to example 6.13. So the question asks you to draw the influence line for the shear in panel CD of the floor girder in figure 6.21a. Shear in panel CD. Yeah, this one. Okay. So in that case, if you want to, before this we already know there are two approaches to draw the influence line. The first approach, whether you want to use tabulate values, or the second approach is to use influence line. Yeah? So here in this example, they use the first approach, which is tabulate values. Yeah? So here, shear in panel CD for the floor girder. So meaning that you need to move a 1 unit point load along the girder. So in this example, they start with 1 unit at A here. Yeah? 1 unit at A, then you can find the Fy. So once you know the Fy, then you can do cutting or cut the section and get the VCD here. So based on this value, you can prepare a table. So you can see, if you place 1 unit at 0 meter here, then your VCD is 0.33 here. Okay. Now let's say if you move 1 unit at 6 meter here. This one 3 meter and this 3 meter. So it happened to be here. Again, place 1 unit and get the BY. So 1 unit, this is straight away applied to this beam. Yeah. So once you have this 1 unit, then you can calculate what is Fy and what is GY. Yeah. In this case, they do the submission at G, so you don't have to calculate what is GY. Yeah? So you can straight away get the Fy. So once you know the Fy, then you cut the section to get the VCD. Yeah? So using method of section, you have known the Fy, then you can get VCD. So use this VCD as this value. Yeah? The internal shear values. So once you have this, you will draw the influence line. So this is what we call influence line. Yeah. You can check also if you move the 1 unit at 9 meter. Yeah. Let's say here 9 meter. See whether you can get this or not. And then move again to 12 meters, see whether you get VCD 0 or not. Yeah? End up, you can draw the influence line here. If you place 1 unit at 0 meter, then this is the value for VCD. If you place 3 meter for 1 unit, then you can get the VCD is 0. And you move along the floor girders. Yeah? So this is what we call influence line for VCD. Yeah? So this influence line only shows the value at CD. Yeah? Based on the unit load that you put in this panel CD. Yeah? meaning that this VCD is moved along here to here, yeah, here to here, to here, to here, and to here. Okay, so I hope you can understand. Thank you. So we will continue for another slide or another video.